Today I'm going to talk about the durability assessment. I'm going to explain why we are investigating the durability of the houses. I'm going to explain how we collect data and how we're going to use the information that we gather. So first of all, let me tell you what the durability assessment is. Well, it quite simply means that we monitor the physical durability of the different elements of the star homes over the duration of the study. We monitor how different building elements might be worn from occupants' use, how elements might fail or break down, but just as importantly, we monitor which elements do not show signs of wear or are prone to breaking. Now, in contrast to many of the other investigations in the study, we're not comparing the durability of the star homes with the traditional houses, that is, the intervention with the control. The point here is rather to examine how the design solutions and materials used in the star homes perform over time when used by the occupants. Now, there are two reasons for monitoring the physical state of the building elements. One is because the house, the star home, is the intervention in the study. So in order to have valid data, we're interested in keeping the intervention as constant as possible, so to speak. Constant across space, meaning that all of the 110 houses have to be identical, and constant across time, meaning that they should not change over the duration of the study. Or at least if they change, that change should apply to all of the houses. It should be controlled and it should be registered. This is important in order to avoid confounding effects of, for example, a broken netting on a facade, which could potentially allow access for flies or mosquitoes. The other reason is that this study will conclude with proposing a plan for how to scale up those design solutions which have performed well in the star homes. And that could potentially be the entire house with all its design features and building elements. But it could also be that parts of the design have performed very well, while others have not. And that knowledge is very important when considering the next iteration of a healthy home and how it can be scaled up. So how do we do this? Well, we're operating at two different levels to achieve this. First of all, we have a maintenance staff who is standing by to respond to requests from the occupants if something in the house breaks down or other unexpected events occur. That is a running task, and the main purpose is to keep the intervention constant, as I said. The other level is a series of inspection rounds where we systematically check all of the 110 star homes. We use a checklist to capture all changes of the structure, both if something is broken or worn out, but also if it's not. And importantly, we also register if the occupants have made repairs themselves or alterations. In today's session, I'm going to focus on the latter, that is, the inspection rounds. So first of all, this way of capturing data about the houses, where we exclusively look at the physical state, is not the sole source of information for evaluating the house design and the scale-up strategy. We are combining knowledge from the durability assessment with knowledge about how the houses are used, how they are perceived, and of course, the health effects we are investigating. So this architectural knowledge will be brought together with anthropological, epidemiological, and entomological data to give a comprehensive picture of how to further develop and scale up the design. Now let's speak about the method for capturing data. What we want to have at the end of the study is an exhaustive overview of the performance of all building elements. So imagine a table where you can see all of the building elements in all of the houses and how those elements have been recorded to perform over the duration of the study. Now, some of the building elements, like the netted facade, for example, is well outside of the local building tradition. So we want to know how it actually works as a facade. Will it be prone to tears or not? Are some areas more exposed to potential tear than others, like close to a door, for example? Now imagine that you inspect the 110 identical houses 4 times, and every time you see that in many of the houses the net close to the door handle is torn, even though it had been repaired after the last time you noted that it was torn. This knowledge would give you a very good indication that there is a design issue to be addressed here. Now, I'm not saying that that is the case, but I'm trying to illustrate the point with a hypothetical example. This we're interested in doing for all parts of the building, so that at the end of the study, we'll be able to evaluate which elements should be reconsidered. So the way we do this is by a series of inspection rounds, in which field staff visits all of the star homes within a certain time period and registers the state of each building element. It's a visual inspection, and the field workers use a checklist to go through all of the building elements. For each element, like the front door, for example, there are 3 options to choose from in the form. Either the element is noted to not have any issues, in which case the answer is registered and no further action is taken. Or the element is registered as having an issue, which can then be further detailed in words and in photos. There's also the option to register if occupants have made repairs themselves to elements that have been broken. We are using a digital form, which was developed based on the tectonics of the house, so there are different categories in the form which reflect the materials and structure of the houses. And if we find that a building element is broken, we organize a repair or replacement for the safety and well-being of the occupants, and because, as I said before, the house is the intervention and it should be kept constant throughout the duration of the study.